Use the Pythagorean theorem to determine the length of the line segment shown on the grid. Answer as an exact value and as a decimal to the nearest tenth. In order to use the Pythagorean theorem, you have to turn these line segments into triangles, and I've done that for you right here. We're going to start off with line segment AB. Now the line segment AB is also the longest side of the triangle. It's also considered the hypotenuse. So it's going to be that line segment squared is equal to A squared plus B squared. Now to figure out A and B, what we're going to do is we're going to count the squares on each side. Let's start with the vertical side. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There's 10. For the horizontal side, we have 1, 2, 3, 4. 4 units. So it's going to be 4 units squared. So working this one out, AB squared is equal to 100 plus 16, which would mean that AB would be the square root of 116. So since we're finding an exact value, you have to reduce this. The square root of 116 is the same as saying the square root of 4 times by the square root of 29, and that works out to about 2 root 29. As a decimal, rounded to the nearest tenth, this is the same as 10.8 units. Let's work with CD. So the line segment CD squared is the same as C squared plus D squared. Let's start off with the vertical part. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 units. And that's going to be squared. Plus, let's take a look at the horizontal. We have 1, 2, 3, 4 units. So working this one out, what we have is 64 plus 16. So the line segment CD would be the same as the square root of 80. Now this can be broken down. This is the same as saying the square root of 16 times by the square root of 5. 16 is a perfect square, so this is the same as saying 4 root 5 units if you want an exact answer. Now as a decimal, this is the same as 8.9 units.